Okay, so the base is, first property is base being common, or we can also say same base, common base. The second one is base being common, indices different. The second one is base different, yeah, indices common. So two different set of properties, two different sets of properties. Okay, so let's go with the very fundamental. Even before these properties come, the one more fundamental thing is, I would probably call that is which I explained, 2 to the power of 0 equal to 1, 100 to the power of 0 equal to 1. These are the very fundamental things even before we have the base being common or whatever. Okay, so I will write that in the next page. So the properties wise, and I'll write left side the exponents. It's better to compare both the things like that only. So we have exponents here and we have logarithms here. So the first one is index being 0. Index is 0. So absolutely anything other than 0, anything other than 0 to the power of 0 equal to 1. That's the first property here. Okay, the same thing, actually the same thing translates into log 1 to the base of anything other than 0. Log of 1 to the base anything other than 0, yeah, that's equal to 0. So this 0 is, wait a minute, anything to the power of 0 equal to 1. Okay, so this 0, index is 0, right? That index 0 is, index is coming to this place. So this is the first and foremost property. Okay, the second one is, so if I have, this is called a reciprocal property. So yeah, reciprocal, that means a is considered a to the power of 1, 1 by a is considered a to the power of minus 1. Okay, so a is considered a to the power of 1 and 1 by a is a to the power of minus 1. Here the corresponding property, if you are looking at, if you have what is the log of something and log of 1 by something. Okay, so how that gets translated here is log a, for example, equal to 2. Say for example it is 2. Yeah, say that means if log a equal to 2, okay, if log a equal to 2, log of 1 by a would be log 1 minus log a, which you will see later the properties. Because log 1 is 0, you will have minus log a, which is minus 2. So log 1 by a is minus 2. Okay, in this case minus 2. If whatever is the value you have here, that minus will come. If this value is 3, then you will get minus 3. If this value is 4, whatever. So basically you would say log a is minus log 1 by a and vice versa. Log 1 by a is minus log a. That's the reciprocal property. Okay, Now you will be able to understand because you already have some detail on the logarithms. Okay, but if you say this initially without telling log m minus n, log m minus log n, you won't understand that. So anyway, this is the second property. So we are going to the third property. So the third property is addition. For example, you are adding two things, which is a to the power of m plus a to the power of n. Okay, is the same thing, a to the power of m plus a to the power of n. No change. So here, if you are adding, for example, so if you are adding 2 log a plus log b, something, of course the base is a common base. Okay, you can consider this base as 10 and this also as 10. Okay, this becomes log ab to the base 10. Yeah. Okay, so the fourth property here, subtraction, adding or subtraction, I will just say or subtract also, it will be same thing. So you can have a minus, it will be still minus. Okay, in this case if it's a minus, you will have log a to the base 10 minus log b to the base 10 equal to log a by b to the base 10. See, they're actually the same rules, logarithm rules. I'm actually combining them and classifying them in a different way. Okay, yeah. So if when you do a multiplication or multiplication and division, that means if I have a to the power of m multiplied by a to the power of n equal to a to the power of m plus n. See, I have not put the equivalent arrows to this side. Okay, for something I had put the equivalent I had put here. Here I just said correspondingly. This is not equivalent. Okay, understood, right? A corresponding rule here. So wherever there is equivalent, I'll put the double arrow. Okay. I'm actually putting the double arrow to indicate that this gets translated to. This is the conversion. This is the conversion. Okay. What we are doing is we have to say this is a to the power of m plus n. That means you are getting logarithm of m to the base a and multiplied by n. So this this is mn is multiplied. This is a product. This is a product. Okay. So you will have as log m to the base a plus log n to the base a. Okay, this is an equivalent thing here. So this is coming from here only, log a to the power of m plus n, and that's why this is coming like that. Okay, log mn is log m plus log n. Okay, then the next one, you will have a to the power of m divided by a to the power of n, then that gives a to the power of m minus n. So on this side correspondingly you will have log m divided by n to the base a. See, the basis, this is what you are actually seeing, the base is common. Okay, yeah, then that gets translated to log m to the base a minus log n to the base. Okay, so I will give the generic part here. Okay, if this was easier, you could understand. That's why I write only for this. Okay, yeah, yeah. Log of product of ABC, or let me say x, y, z, equal to log of x sum of, okay, log x, log y, log z. See, the product inside the log will become sum of the logs. Okay, this is the rule. Yeah, sum of these logs. Understood, right? This is same as log x to the base a plus log y to the base b, sorry, base a plus log z to the base a. Okay, both mean same. All right. So the next rule. Any doubt? Any confusion? Okay, good. So the next one, we have the divider. As such, we have to see the exponents. And logarithms. So fourth one, fifth one, we are here. That means raising to another index. It's already raised to the m. You are raising this entire thing to another index. This is what I mean by another index. That's nothing but a to the power of mn or a to the power of nm. So this, yeah, you want me to repeat this? You got it. Yeah, multiplication. Yes, this becomes a multiplication. So, and then if you look at here, you have log something. I mean, we are interested into this part only. Okay, log m to the power n base a will be n log m to the base a. This n will come to the front. So all these are two-way streets, meaning if I have n log m, for example, then you can take it to the top. These are reversible, meaning you can come this way to this or the other way around. Okay, here also same thing. Okay, these rules are actually bidirectional. If someone has given this, I could write this. Yeah, both ways. Whenever actually equal to is there, that symbol, right? Equal to and identical or congruent. If you are equating left to the right side, and then the right side also can be equal to left side. This is what, you know, sometimes when we are solving the equation, you got like x minus 5 equal to 20. So one person can write this as x equal to 25. The other person could write this as minus 25 equal to minus x, and therefore 25 equal to x. Both are one and the same. Okay, you are saying 25 is equal to x here. Both mean same, right? Yeah. So that's what I mean. You have to come from both directions. It can be left or right, you know. So this is basically raising to the power. You got raising to the power. Okay. So more or less with a common base, these are all the rules. The next rule is with the different. Base is different, index same. That's the next one. Okay. So yeah, I am telling the next set is base different. Yeah. index same. So for this again you have the same division here. So that goes with exponents, and here logarithms. So the bases are a, b, and you have the same rule. For example, these are the bases. The first one is a to the power of m plus b to the power of m. See, the indices are same. Okay, no change. Addition or subtraction, no change. Okay, correspondingly here you have, for example, log a. Oh, I should take a different one. So log x, okay, plus or minus log y. We wanted the bases to be different, right? So this has to be same, isn't it? So I'll have a log x to the base a and to the base b. Okay, no change. You can't do anything with the plus or minus. Then comes the second property. What we have is the multiplication and the division. So a to the power of m multiplied by b to the power of m. So what we do is bases are multiplied together, a and m, no change on the index. No change on the index. Okay. See, here you cannot apply this is the same rule I said, right? In this case, for example, you have the bases ought to be different. So log x to the base a multiplied by log x to the base b. No change. You do, because the entire logarithms works on the base ought to be same. That's why I'm actually writing all this stuff. Okay. So the logarithms work primarily on the base being same. So multiplication and correspondingly division, if you have here a to the power of m divided by b to the power of m, that's a by b to the power of m. Here also, yeah, no change. For example, you have log x to the base a divided by log x to the base b. You will get another rule, we'll come to that. You can actually consider, for now it's no change. You just retain that way only. So this, the last one is I have a to the power of, and is there an index, like you can raise it to the same power or whatever. Okay, so indices are to be same, and a to the power of m whole to the power of n multiplied by b to the power of m whole to the power of n. It's equal to a to the power of ab to the power of mn. Yeah, I'll just write it properly. Okay, so this is a to the power of mn multiplication. Okay, and here there is no such thing, but let's write that actually. You have log x to the power of m to the base a, and whatever is the thing multiplied by log y to the power of, or x to the power of n to the base b. What at the most we can do here in this case is you can bring the m to the front and n to the front, but you can't do any other thing. Got it, right? So these are all the rules what we have. Now go back where I said the bases are different, indices are common. Okay, this is the one we talked about just now. Okay, so all these rules will not have any meaning if you do not have an example. For everything we should have an example. Okay, so let's go back to the first one. So this is the one. We have an example, anything to the power of 0. That's, we got these values. First one is easy. Second one is also, if you want to have an example, you can go with an examples here. So 20 to the power of, this is equal to 1 by 20. That's equal to 20 to the power of minus 1. Okay. If I have, no, this 1 by 20 is 20 to the power of minus 1. This fellow is not this. Okay. So 1 by 20 is 20 to the power of minus 1. Okay. In this case, this side, log of 1 by 2 equal to minus log 2, or log of 1 by 10 equal to minus log 10. These are the examples. Okay. So examples are in yellow. Okay. So the next one, it's kind of revision also. Okay. So just going backward and add 8 power of m and the power of n. Since it's a no change, we don't need to write. Whereas here, log of this. Okay. If I have an example, so log log 2 to the base 10 plus log 3 to the base 10 equal to log 6 to the base 10. In fact, this can be the one which we can use indices. The base is same, right? The base same. Okay? Base is same. So that's what this example is about. Then for the product here, we write the same thing. Log 6 equal to log 6 to the base 10 equal to log 2 into 3 to the base 10, and that can be written as log 2 and log 3. Okay. So then comes, so product of x was, if I have log a b c d e f to the base 10 equal to log a to the base 10 plus log b to the base 10 plus log c to the base 10 plus log b to the base 10 and so on. Okay, plus log e to the base 10 plus log f to the base 10. Okay, so now raising to another power. So if I have 2 to the power of 5 to the power of, this is equal to 2 to the power of 15. So on the other hand, if I have 2 to the power of 8, I can write this as 2 to the power of 4 to the power of 2. I can also write this as 2 to 2 square to the power of 4. I could also write this as 2 to the power of 2 to the power of 1 by 2 whole to the power of 16. I can keep on writing that many forms. So on this side, I have log 2 to the power of 5 to the base 10 equal to 5 log 2 to the base 10. If I have For example, half log 25 to the base 10. So you can take this to log 25 to the power of half base 10. The half can be this, okay, or the 5 can be. So when it is empty, it can come. When you want to make it empty, you can take it to the top. Did I confuse you further, or you are able to understand better? Better, right? Okay. Yeah, because I just want to make sure, you know. So these are not the so many rules you just need to be memorizing and all the things. But if you understand the concept, these are very, very easy. Okay. So these things, as I said here, 2 cube multiplied by 5 cube. So we are seeing index same. That's why you multiply then to the power of 3. Okay. So here, since there is no change, we don't need to. This one 2 to the power of 3. Correct, for this. Okay, for this. The example is for this. Okay. So if you do more questions, then you will be able to understand better. So let me see whether I have some questions ready, and then I'm trying to take a snap of a thing. So give me some time just. Okay, so we have the next. We'll be looking at. So you see some questions there. Okay, so let's try looking at these. Are, as you said, exponents are a little bit easy, so we will look at how these things are done. Okay, so this one, how do we convert this? Or he's just asking you to find the value of y. Okay, so I am seeing the base. Another rule what I said at that time, which probably I have not said at this time, is if I think this rule also we will add it up and then we will go further. Okay, so the last rule is anything to the power of 1 is a. Anything to the power of 1 is that itself. Okay, that gets turned to, if you have this and this same, then that's index equal to 1. So when we are doing the questions, we will try to bring all these things into one of these rules. Okay, see, I am just looking at 25 as a 25 as a 5 squared to the base 5. So I am on the left hand side. I have taken the left hand side of the equation. So this, now I am seeing some power here. So I apply the last rule. This one. So whenever I have something power, right, this one m comes to the front, we said, right? No, no, here is only one thing. There is only one logarithm. We don't have two logarithms, right? There is only one logarithm. So this exponent will come to the front. Understood? This, what is the rule I am using? I am using log m to the power of n to any base, okay, equal to n log m. So this one will come to the front. So that's the one I am using here. Okay. Yeah, yeah. So going to into the front, I have here, which is 2 log 5 to the base 5. So the answer is 2. This 2 is 2. Okay. Log 5 to the base 5. Hello? How much is that? Log 5 to the base 5. 1. Good. So the answer is 2. So that means 2 equal to y. Equal to y. 2 equal to y. So that's how we got y equal to 2. Then this one, second question. Log 3 to the base 1. So remember log 1 of any base. So we go back, log 1 of any base. In the beginning we said, right, log 1 any base equal to 0. That's it. So by applying that, we just said 0 equal to y. Then again you see 4 and 16. I would like to write 4 in terms of 16 so that I can apply the same rule. So what's the relation between 16 and 4? It's the square root of 16 is 4, right? Isn't it? So but how do I write in terms of 16? That means 6 power of half is 4, right? Therefore I'll write this as log 16 to the power of half to the base 16. So the 4 is converted into 16 to the power of half. Better, so that I can apply this rule, right? So you get half log 16 to the base 16, which is equal to half. Yes, yes, yes. Can you try this now? Fourth question, fifth question, and sixth question. You can try. So if fourth one is little tougher, you can go for the fifth one. You don't have to do out of 4, 5, 6, whichever is easy for you, you do it first. Uh, the fourth, this one, right? Fourth one. Fourth one is pretty easy. So we have base as a 2, right? So we have to write that as logged 1 by 2 cube to the base 2. Now then we have to use the m by n formula. Log 2 first is 1 minus log 2 cube to the base 2. This is 0 because log 1, right? So that's why it is 0. Then this one, the 3 will come to the front. So 3 log 2 to the base 2, which is minus 3. Okay. Fifth one, straight answer. Fifth one, you know it. Yeah, correct. Good. Y is 0. The next one, sixth one. Yeah, do it. Four, 8, 12 are similar actually. Fourth one, eighth one, and 12 very very similar. Hmm. Correct. Good. So the 3 will come to the front, right? Hmm. Yep. Correct. Y equal to 2. Sorry, y equal to 3. Yeah. Nothing, right? Great. You got something like 3 log 2. 3 log like this, isn't it? Yeah, this one you know anyway, right? This value is that's 1. Why it's 1? Because the base and this are same. So the y equal to 3. There. This is 3. Okay. Seventh question is, as I said, similar to the fourth one here, but then how do I write 7 and this? So you just have to use, I will just say for 7 you use log m by n rule. So what is that log m by n rule? Log m by n equal to log m minus log n. So like this I used here, you see, I used here. So log numerator minus log denominator. So if you want, you can do them as a homework if you would like to. Otherwise, you continue also. If you think you can get confidence by doing it now, you do it now. Okay. Okay. Uh, minus 2, I think. Because 9 you can write as a 3 square, isn't it? Ah, 1 by 9 is 1 by 3 square, correct? After that, you have to do this one, what we have seen here, right? Like this. Yeah, like 1, the numerator will come, minus log 3 square will come. Not base 2, right? Base 3. Base 3, 3 square you will get. Hmm. Minus. Hmm. 3 square, right? Oh yeah, correct. 2 came, yes, correct. 2 came in the front. Minus 2. Minus 2 is correct answer. So this one, now we can't disturb y. Ninth question, you can't disturb y. We have to write 32. We have to have some relation between 32 and 5. So definitely, I mean, that should be the relations between 32 and 5 is how do we raise something. It can be, you have to think of the prime factors. A and b 2 to the power of